The curve C has equation y equals x times 5 minus x, and the line L has equation 2y equals 5x plus 4. Use algebra to show that C and L do not intersect. B. In the space on page 11, sketch C and L on the same diagram, showing the coordinates of the points at which C and L meet the axes. So here's the question then, let's have a little look at it. Show that these points do not intersect. So here, the points intersect when so sub y equals this into this, then 2y, so 2 lots of x, 5 minus x, so there's y, and it's 2y equals 5x plus 4. So let's expand the bracket then. We get 10x minus 2x squared, 10x minus 2x squared equals 5x plus 4. Move everything over onto one side. Let's move the 2 minus 2 over, so it becomes 2x squared. Move the 10x to minus 10x. 5 take 10 is minus 5x's. There's already a plus 4 there. Everything's been moved over, so read it from right to left then. That equals 0. Here, b squared minus 4ac then equals b squared is minus 5 squared, which is 25, minus 4 times a, 2, times c, which is 4, equals 16 times 2 is 32. 25 take 32 is minus 7, which is less than 0. So no solutions. So no solutions, and hence no point of intersection. Okay, that's part A done then. Here the point intersects. The point intersects when? Okay. Okay, so they don't intersect. Sketch C and L and show the coordinates where C and L meet the axes. Here's C and here's L, so we need to write them down. Let's do the axes first then. Okay, here's an axis then. One of the curves was y equals x, 5 minus x, wasn't it? And the other one was 2y equals 5x plus 4. Okay, this is a straight line. If we just divide by 2, y equals 5x over 2 plus 4 over 2, move the 2 from times to divide on this side, is 2. So the intercept is 2 and 0. It's a straight line of gradient 5 over 2, which is 2.5. So let's draw a straight line then. Try and draw as best I can. So draw like that. Should be a bit steeper really, but that will, because it's of gradient 2.5, and this is the line y equals 5x over 2. Or we could rather write it like this, couldn't we? So let's do that then. 2y equals 5x plus 4. And then we've got this thing here, which is minus x squared. When we expand the bracket, I'll write that term first, plus 5x. So the roots are at 0, 0, 0, and also at 5, isn't it? 5, 0. So there's the two roots. It's a minus x squared, so it's an n-shaped quadratic. So let's just draw it then. It's going to come up, turn, and then just, oops, then just go back down. I've got torn a dashed line because it's a digital pen. So here's the quadratic then. 5 minus x here. That's where it cuts the axis here. The only point we haven't put down is this one here. So when y is 0 here, when y equals 0, x is, when that equals 0, minus 4 fifths. So it's minus 4 fifths is the x value when y is 0. So that's that point there. So there's all the points marked on the axes where they cut, and the two sketches are done.